would request Sai Bharadwaj to present his work.
Hi everyone, good evening. Thank you GradsKey for giving me this wonderful opportunity of presenting my work. And without further delay, I would like to go into the details. Yeah, so what I'm going to present today is called Craft, which is Custom Resource Abstraction and Fabrication Tool. This is some work that I have done during my internship in Salesforce during summer 2020 on Kubernetes, and I will get into it. So a quick intro about me. I am Bharadwaj and I am doing my BTech in Department of Computer Science, IIT Madras. I have done my internship, summer intern at Salesforce Hyderabad, which is where I got introduced to Kubernetes and these concepts first. And I took an immediate liking to it and I continue to work on that. My interests as of now include cloud computing, which is expansion of Kubernetes and container security, and deep learning tree-based models. I have just done intro courses in them. I'm still exploring. My hobbies include reading novels and playing all outdoor sports and watching cricket. So yeah. I'll just, before going into my project, I would just like to give a brief overview about operators and Kubernetes and operators. So as Kubernetes, as it's becoming popular nowadays, Kubernetes is a container orchestration engine useful for deploying containers on clusters. Most of the cloud native stateful applications are being deployed on Kubernetes nowadays. Kubernetes offers a set of resources for us to deploy our application on, but most of the times we would like to apply our own customizations to the existing resources to make it suitable for our needs, which can be which can be done using custom resource definitions. So by using custom resource definitions, we would be using the extensibility aspect of Kubernetes, and we would be deploying our own applications onto the cluster. Now, after we create an application and deploy it on the Kubernetes cluster using CRDs, custom resource definitions, the big problem usually faced is that we need to deploy service teams to manually oversee certain tasks like monitoring and logging, validation and access, failure management, security, etc. So all these tasks have to be manually overseen by someone or a team in the application that we have deployed. So these tasks, all these tasks that have been just mentioned, can be automated using concept and software extension to Kubernetes known as operators. So, to put it in simple words, a Kubernetes operator is a method for packaging, deploying, and more importantly, managing a Kubernetes application. So, a Kubernetes operator take the promise of automation of Kubernetes to the next step. Kubernetes operator consists of three parts: a custom resource, as pointed here, a custom resource definition, controller, which acts on a controller which acts to drive the current state of the application to the desired state, and the CRUD API, which is the create, read, and update and delete functions of the user, which are programmed into the which are given into the controller. So the actions that a Kubernetes operator can perform can include from scaling an application to version upgrades, to managing kernel modules, to managing failures and reconciliation, periodic reconciliation, and we can even manage modules for nodes in with specialized hardware using operators. So operators eliminate the need for special teams to oversee monitoring, logging, failure management, etc. So this is so as we can see right here, operators have a huge application in the software industry. However, right now, operators operators consist of lot of complex code, lots of complex code, and they are incredibly difficult to write. For example, operator for a sample WordPress application, which is developed by Press Labs and is available in GitHub, consists of 3771 lines of code, which is just basically the CRD and the controller part, which is it does not even include the metadata required to deploy the operator to manage the application. So writing all these 3771 lines of code, or how many ever lines of code, takes up a lot of time, and more importantly requires high expertise in the concepts of Kubernetes from the developer, which might not always be the case. And currently there is a language barrier for writing operators and using them, because they can only be written in Golang, which is a language Kubernetes is written in. So what makes the life of a developer easier? We can, if there was a tool to auto generate our operators, if we give our CRUD functions, create, read, update, delete functions, and the custom resource definitions as metadata, as input, this will make our life easier, right? So that is exactly what Craft, the custom resource abstraction and fabrication tool, attempts to solve. So Craft stands for Custom Resource Abstraction and Fabrication Tool, and it is the first tool to create native abstractions declaratively. So all the developer has to do is give his CRUD API and his CRD definitions in form of metadata, and Craft creates an operations with a single command, with only one command, and around less than 15 minutes for complete creation and deployment, which is a huge bonus, because writing an operator on its own can take more than 2 days, even with experienced developers, right? So this is the diagram, the flow chart for Craft, wherein we give inputs controller.json, resource.json. Both of these will contain this. Controller.json contains our customizations, CRD, in form of metadata. Resource.json contains our schema for validation, and resource Docker file contains our CRUD functions in an API, CRUD functions in a language of our choice. So when we give this to Craft, and Craft generates operator.yaml, which can be directly deployed onto the Kubernetes cluster. With operator.yaml here contains all the metadata required, and operator Docker image and resource Docker image, which are both deployed onto the Docker registry. So I'll just show, I'll just quickly show the command that we give to Craft. So as you can see, right. So this controller.json and resource.json are the two files that we give as input to Craft, along with another file which is the resource Docker file. This is the resource Docker file. So now let me execute the command. So this is a single command which will create the entire operator, which will create the operator source code. It will generate operator.yaml. It will build operator and resource Docker images and push them onto the Docker registry. This will take a little bit of time to execute. So I have already executed this before starting. So I'll just show the code base that it generates. As you can see, this is the WordPress operator source code that has been generated. It contains the API, the controllers required, and the reconciler with reconciliation features and everything, etc. So this can be now deployed onto the cluster and used to manage the WordPress application. Yes, regards to the code base, so this is the code base of Craft, which consists of the basic CMD, create, update, delete functions, and some base operator, reconciler code, etc., which are required for the Docker file processing. So what makes the craft special and what are the advantages? So first one, easy onboarding. So craft removes the language barrier which is present in the which is currently present in Kubernetes, which is operators need to be written in Golang. But with craft, in the resource Docker file that you give as input, you can write your commands in Python, in Java, whichever language of your choice, but craft will process it as a Docker file. So that will remove the requirement of Golang. Next, we have our the segregation of duties. So craft essentially makes it possible for the developers to only work on the Docker file, which contains the CRUD API, which is basically what the developers want. And while the configurations of the operator can be separately worked on by the site reliability or DevOps engineers. Versioning is another feature of craft which makes it possible to work on a different version of an operator but still get the same results, because of the reconciliation features which we valid and validations. So the another benefit is that the schema input and runtime validations are available in craft. When the resource.json file that we give in as input to craft makes it possible to get feedback on input time, build time, compile time, and runtime feedback of the operator. And controlled reconciliation. This is especially a useful feature of craft, that you can manually define your resource frequency, reconciliation frequency, to lower your maintenance workload. This will especially be useful in branch management operators, wherein certain branches will only need to reconcile when required upon. They don't need to be reconciled continuously. So you can define your reconciliation parameters such that it will only reconcile when you give the command, and thereby this saves unnecessary workloads. Some additional features of craft are vault integration and secret management, which make sure of the security of your passwords, everything, etc. So these coming to some metrics, craft during my time at Salesforce, we have used craft to create some operators with some very interesting results. Over 260 run list steps from the run book were being converted into three kubectl resource files, which kubectl resource files essentially just need to be deployed onto the Kubernetes cluster. All the auto integrations, branch management, and client spec management are all being done by operators which have been generated by craft. This was only possible because the developers were able to write in a language of their choice, and they essentially just needed to declare the CRUD API, whereas the site reliability engineers worked on the customizations required. And this is a scenario where before craft, where a single auto build creation took around 5 minutes for experienced developers, and when 300 plus auto builds were required to manage, it took more than 1 day to manually write the code for every one of them. Whereas after craft came into existence, all the 300 auto builds were able to be generated within 15 to 20 minutes by making use of the YAML files and the kubectl resource files which are required. So this clearly shows that there are the immense usefulness of craft. So further research areas that I am currently working on I am working on with in parallel to the Salesforce developers who work with me, integration with Q Plus. As you might probably be knowing, Q Plus is a tool which simplifies discovery and usage of custom resources for site reliability engineers. We are currently working on the operator which is generated will be integrated with Q Plus, so making it easier for the DevOps engineers. we are currently working on reducing dependencies. Currently, one of the slight drawbacks of craft is that it takes some time to process because of the numerous dependencies. So we are currently working on the reduction of dependencies, and the code base is quite large right now. We are currently seeing if we can improve efficiency in terms of code size, because while installing craft, it's to make it truly binary. So these are the further research areas that we are working. So this is the my project. So I'll stop here. Thank you for giving me this opportunity.
Thank you, Sai Bharadwaj, for presenting. Now I request others to review his work.
Yeah. So, Sai, it seems that so you guys have done a lot of automation, right?
Yes, sir.
Yeah. So this, can you give me some insight into how is craft working, and the point which you made, right? That it now you have changed the language dependent task to a language independent kind of a task using craft. So
Yes, sir.
these two things, if you can explain, it would be great.
Uh, yes, sir. So I will explain this using the code base. So you can see the code here, right?
Yes. Yeah.
Yes. So currently, what I meant by removing the language dependency is that now, for example, this is our WordPress operator which has been generated by Craft. So I will go into the example from which I have generated this. Yes. So what I now currently, by removing dependency, what we have done is we have introduced a Docker file through which all Docker file, and we have also implemented exit codes for the Docker file to be processed, so that now when you write your commands or your create, read, update, and delete commands in Python, let's say. Suppose here, if you can see, all the init, create, update, delete, and all have been written in Python. Now, instead of directly implementing on Kubernetes, your create, read, update, delete commands will be implemented via this Docker file, which will be via this Docker file, which will be called upon by Craft. So here, if you can see in Craft now, I have this code map wherein I call upon this Docker file. I see the output that it gives, and I return these exit codes in which will again be according to the exit codes. The further processing will be done in Golang. So essentially, what we need to do is now, if you can declare in a language of your choice. You can write your CRUD API in the language of your choice, and write a Docker file which essentially makes sure that where you can make sure that the Docker file is being executed in the language of your choice in the container. So now the language barrier is removed, in the sense that instead of directly implementing Golang on Kubernetes, we have first implemented it in a Docker file, which will be deployed on Docker, and which will be called by the operator.
Okay. Okay.
Does that answer your question, sir?
Yeah. Yeah. Sure. Okay.
The working of craft is also so in the reconciler, whenever we reconcile, which is where we'll call the create, read, update, and delete functions, right? So the reconciler does, instead of calling the CRUD API directly, the reconciler here, yes, reconcile runner.go. If you can see, it will call the Docker file instead of directly calling the CRUD API. So since the Docker file you can execute in Python, or we can execute in Java, any language. So this will eliminate the language barrier.
Okay.
Okay. Hi, Sai. I think this is a wonderful work and you presented it really well. I would like to know, are there other tools that do similar kind of a job?
Yes, ma'am. Actually, so the thing is, Craft was built on a couple of tools which do part of the job. I would like to say. For example, there's a tool called Cube Builder, which is officially released by Kubernetes, which creates a sample controller. It does not generate an operator with the customizations that you want. It will generate a sample controller which can essentially, for which you have to give the CRUD API in Golang, and you have to give your CRTs manually hard to manually code it. And there is another project known as Operatify, which will implement a reconciliation part that I have shown here that the Craft takes. So Craft drives in the Operatify will implement like what Operatify does is it takes the project after you write your CRUD API, you can use Operatify to add reconciliation part of the code into it. But both of these projects, first of all, require the developer to write code in Golang, and both of these only achieve part of the projects. You still have to write your controller logic on your own. The Craft goes one step further in the sense that you just have to write the CRUD API, and they will implement the controller by ourselves. Does it
Oh,
answer your question?
yeah, it does.
Hi, this is Praveen here. Can you hear me, Sai?
Yes, sir. Yes.
Yeah. Thanks so much for taking us through this your work. I have one question, which is more related to your own contribution. Can you explain which part of this was your contribution and which was it through all your collaborators?
Yes, sir. So right here, uh, so as I just explained to Umeha ma'am, the reconciliation part inspiration was drawn from a previous point called operatify. Right. So the reconciler part in operatify previously was of a fixed determination, and it was only for it was only for Golang and it. So what my contribution here was that I brought the reconciler part and changed it such that whenever the reconciliation calls the CRUD API, it goes to the Docker file instead of, I wrote it in such a way that it goes to the Docker file instead of the CRUD API. So that was like, that removed the language barrier, right? That was one of my contributions. And another one of my contribution was the interface, user interface, command line interface. But yeah, that's more of just coding, hard coding, I can say. This was my main contribution to the project. And the rest, building the controller and sending the control from the controller to the reconciler was done by my collaborators. And the reconciler part, removing the language dependency, was
Okay, thank you. And one more question related to this is: have you tested these for with other kind of operators and other use cases than the ones that you were actually given to?
As of now, we are currently in the process of testing. Craft has just been open sourced. At Salesforce, we have tested for all the operators that I have shown, auto integrations, client spec, etc. We have also tested for a few MySQL. We have tested for WordPress, and we have tested for Cloudy Boy and some PaaS browser as a service operators. Some few ones. We are currently we have outsourced so that what we could get a chance to test with different kinds of operators like Prometheus.
Okay, thank you.
Thank you, sir.
Thank you so much, Bharadwaj, for presenting. Thank you so much, artist, for reviewing his work. Yeah, further any feedback you can ask.
Thank you everyone. Thank you for big thanks to GradsKey for allowing me to present. present my work, for giving me a chance to present my work. And thank you, judges, for presenting your valuable insights on this. Thank you.
Thank you, Bharadwaj.
Hey, thanks for watching the video. Feel free to visit our website at www.gradskey.com. Smash the like button below, hit the subscribe button to follow. Also, to get notified when a new video is uploaded, click on the bell icon and you can get a